everybody, welcome back to MBE. This video today is for the drag week people, or the people that are thinking about doing drag week, and why it's so important to run superior components, especially in a drag week application that is extremely challenging. That's a very challenging thing to do. Drag week, 200 to 300 miles you race from track to track, you drive to, and then you have to drag race once you get there. So there's important things. For one, you got to make power. This is a Scott Schwieger. This is his whole top end right here. He'll be picking this up on Monday, but this whole top end is for a drag week, single turbocharger. You can see it has dual fuel rails, and we'll get into that later. We got the elbow on it. But some of the reasons to use why this is so important for the drag week guys. Okay, the valve train is so important because you got something right here, 850 thousandths lift that you're going to go run 250 miles at a time, and you can't change rockers, you can't do any of that to get what you want to do. Well, when you come here, we do all of this. So first we start off with the Moroso valve cover that they make for us. But this has spring oilers, so you just run your dash 4 line right to here, and then these have squirters in them. And it's not just one squirter. They have like 4 squirters on each one. And what they do is they shoot oil on the valve spring to keep it cool. When you want to run 850 thousandths lift and drive it for hours at a time, we have to keep the spring cool. This works incredible. This has been proven in the cup industry. They started running spring oilers probably in 1998, a long time ago. Just goes to show how old I am. But it definitely works. So very important. So we'll do that. Now, let's go to the rocker gear. The reason why the rocker gear is so important is because when you go to an MBE, when you come here, for one, you're going to be able to run 1/2-inch push rods. You're not going to have to run 3/8 or a 7/16 push rod. You're like, well, why is that important? That's not very much. It's 60 thousandths. Well, it is important. When you go from a 7/16 to a 1/2-inch push rod, the push rod is 92% stiffer. It's almost double. And what that means, we can control the loft of the lifter over the camshaft so we can make things live. We can keep things calm. If we can get the lifter to land sooner on the ramp, there's less pressure angle, there's less pressure, and everything is smooth. It just rolls down the ramp. And then, so we have that. So the other thing is, when you come to MBE, we don't have individual fasteners holding the bar on. Yeah, it's 2024. Like, let's do it the correct way. So right here you have 18 7/16 fasteners holding on the rocker bar, a one-piece bar. This thing is stout. And you want it stout. We don't want deflection. If there's deflection, then there's deflection in everything else. Then it's putting bearing, side load, bearing load and everything. This stuff will last forever. This is a T&D system right here. Brad Rounds at T&D designed this for us. It is badass. This thing is really nice. Okay, so we have that. I'll put this over here. Okay, you see the smaller spring? We're going to go to the smaller valve spring technology. So we have something, we run this little spring. This is an 1.310" spring designed by Joe Hornick. It's PSI makes these for him. This is basically all the cup technology that's available to everybody. You got a valve spring that might cost, it's about probably 70% more money, but it lasts 3 times longer typically, and it'll control the valve train, which is the most important part. I always try to tell people, like, you can go half-ass. If you break one lifter because you didn't put a titanium intake valve in it or something like that, you could have bought everything 10 times over. So just, if you don't have the money to do it right, wait 6 months and do it right. But back to this, okay? You got the newer spring technology, you got the spring oilers, this little spring right here, which we've went over that numerous times. When you go to that, we use these tiny little locks. It's a top lock application. None of this is new. This is stuff we've been doing on the cup stuff for 20 some odd years, almost 30 years. So all this is proven technology. So we have all the valve trains going to control it for 850 lift. You don't have to run 850, we can run 700. We can do whatever you want. We have different springs for all of that. You have all of this. So, and then you come, let's go to, now we've got the intake manifold. So what Scott wants to do is he wants to run 2 different injector systems. So he's going to have his street system, and then he's going to have his race system. And all he has to do is just switch over to it. I guess this is very common. I think it's a very genius way of doing things. So you can see the manifold is all ported. There's a lot of time goes in the manifold. Like I say all the time, the cylinder head's only going to be as good as the time we put in the intake manifold. So we chose a Sniper for this application. We thought it was the best. And then we go and import it. We put all our little tweaks on it. And then we have Hogan's put the fuel rails because they're right down the street from us, and that's what they do every day. So you can see how beautiful this turns out. And of course, Hogan's been in business since 1972, I believe, so they know what they're doing. And so have all of that. And then you have the cylinder head. Okay, you can see we don't have a dish on the exhaust valve. These are titanium valves. So no dish on the exhaust. The reason why we don't run a dish on the exhaust is you want the cross-sectional area. So to help dissipate the heat. If we had a dish, it would be less material to help dissipate the heat. So no dish on the exhaust. We're definitely not a believer of that. But you see a dish on the intake valve. That's a titanium intake valve. And what you have is, we have the dish to get rid of the valve weight to control the lifter. It's so important to do. But when you come to MBE, we put a convex on the intake valve. I've explained that in the past. What it does is it makes the valve extremely strong, but still allows us to put a dish in it to get rid of the weight. So it's a win-win all around. So these are all the details. Everything we order is custom. You know, the valves are our print. We order all that custom. It doesn't mean the valve costs anymore. It's just going to the place that knows what they're doing, that's going to look after you so the stuff will live. This is the 18-degree max pull. So we've talked about that in the past. It's oval port. It does not have huge taper rates. Typically on a conventional head, it's real small over the short turn, and it's huge here. So you have these huge taper rates. The port is lazy. The fuel falls out of suspension, and they never make any power. I mean, it's a very inefficient cylinder head, except when you come here, and then we bring the technology up 50 years, and now we have something that has hardly any taper rate, like something you do with a NHRA Pro Stock head or a comp eliminator head. So it actually pulls the charge in much more efficiently. This head doesn't have right and left. It has a right and left port, you can see, but it doesn't have a good port and a bad port like all other conventional heads have. These flow the same. So when they flow the same, the tune-up's easier. So all of that, and then you have a cylinder head that easily flows in the 520 CFM range on a 1020 bench. We guarantee that number. So it will make a ton of power. In other words, the whole idea here with Scott running his turbo application is that we want to make the most power per pound of boost. So if we can if the intake port will flow more air and the cross-sectionals are better for the application, then the intake manifold will see a larger pressure drop, meaning all that air is going into the cylinder. If more air goes into the cylinder, the explosion is larger, meaning that you don't have to twist the turbocharger crazy because everything is more efficient. Everything will last longer. It's just a more efficient way of doing things. And that's really, everything's about efficiency. So, go over all that. You can see all the push rod. You're not going to have to worry about doing push rod clearance, anything like that. You can see the 18 fasteners. There's fasteners everywhere to hold this rocker bar on. And the nice part, typically, the fastener is right here, right in the worst spot, the thinnest part of the port. You can see we got rid of that and we put bosses on each side of the port so everything is extremely rigid. You can see we have 10 threads holding the rocker bar instead of like 2 or 3 with one individual pedestal, which is how all those conventional big block heads are. Doesn't matter where you get them from. This doesn't have any of that. Drag weak, drag and drive, 300 miles at a time. Let's go over everything real quick. Better valve spring technology. Smaller, works better. Spring oilers to keep the spring cool. Elbows, any color you like. One-piece rocker bar with 18 fasteners holding the bar on. We can do steel or aluminum. Titanium top locks, no weight, to help the lift control the lifter. O-rings on the exhaust flange. Half-inch push rods. Ported intake manifold, dual fuel rails. Everything is finished for you to assemble. Everything will fit. Every one of these is made individually. Every build is different. We look forward to speaking to you soon. Have a great week.